Today in the workshop, we'll be working with the Elegoo Smart Robot Car, an Arduino-based design with an incredible number of features. We'll take a look at what's included in the kit, and then we'll put it together and give it a test. There's a lot to get going on today, so welcome to the workshop. Hello and welcome to the workshop. Today I'm going to be working with a really incredible little robot car kit. This is the Elegoo Smart Robot Car Kit version 3, and I've got it here. It comes packaged in this really neat little case. Now, I need to mention that the folks at Elegoo were kind enough to sponsor this video, and they've sent me this car kit, and I'd like to thank them a great deal for doing this. Now, this car kit is nothing less than incredible. It's an Arduino-based kit, and it includes Bluetooth remote, infrared remote, line following, and collision avoidance. And all of it can be put together without any soldering. They've got cables and connectors and shields for everything. So this is a perfect kit for those of you just starting off, for those of you who don't have soldering experience, who haven't built anything with the Arduino before. This would make an excellent kit. It would make a great kit for educators and for students as well. So I'm really looking forward to putting this together. Now, there is a lot to cover in this kit, so much that I cannot do this in one video. I know my videos are pretty long, but if I started covering everything in this kit and all of the things it could do, this would end up being a 2-hour video, and the article would be more like a book. So what I've decided to do is to split it into 3 different videos and articles. So today what I'm going to be doing is I'm going to be unboxing this kit. I'm going to be showing you the parts that are involved in it. We'll put the kit together, and I'll write a very simple sketch just to test out the components. In the next video, we will cover both the infrared and the Bluetooth remote. There's a lot of fine tuning you can do over there to customize it, and I'll show you how to do that. And then in the final installment, we'll cover the collision avoidance and line following capabilities of the robot car kit. So there's a lot to do, so let's begin by unboxing the Elegoo Smart Robot Car Kit. Okay, I've got the Elegoo Smart Robot Car Kit here on the workbench, and I'm about to see what's inside it. So I open it up, and there's a lot of things inside it. There's a little diagram over here of all the different components that we're going to find inside the kit. And on the top of the kit, we have a little card from Elegoo just thanking us for buying it and giving us some customer service information in case we have a problem. There's also a compact disc included with it. Now, the CD contains the instructions and contains the Arduino code that we will use for the car. However, you can also get this online, and I tend to prefer to get the online one just in case there has been an update since the CD was created. But it's a nice thing to include inside there, especially for those who don't have easy internet access while they're building the device. Now let's take a look at what's inside here. Well, the main component is an Arduino Uno, which we have over here. They actually make very nice Arduino Uno clones at Elegoo, and I'll show you when I open it why I'm saying that. There's a feature that they added that I wish every clone would have, so a bit about that in a few moments. Over here I noticed they gave us a few tools. There's 3 little drivers here. So you really don't need anything else but this kit. They even provide little tools for you. This is just a mount for a top of the servo to hold the ultrasonic sensor. And here's the servo motor itself. Now over here we've got a Bluetooth module. And here we have an infrared remote control unit. And we've used these before in some of our other videos. This is the line following device. This is the sensor for the line follower, and I'm going to be opening these packages up in a few moments to show you what's really inside them. Now here are some of the cables that are pre-made for connecting things, and that's what I like about this kit. There's no soldering involved. You simply snap the cables together, so it's really kind of bulletproof. Now that's the top section of the kit. It's a beautiful box, by the way. This will make a great little thing for storing tools and things after you're finished with the kit, so that's an extra bonus. Now, one thing I immediately notice here is they provide 2 LiPo batteries for you, and they also give you, and we'll dig it out down here, a LiPo charger. And isn't that great? So you've got a charger and the batteries for the robot car. Okay, this is a battery box that actually is going to mount and hold the batteries to the car. The traditional cable that you get with an Arduino so that you can hook it to your computer. Okay, here's our ultrasonic sensor. This is pretty well the same HCSR04 sensor we've seen before. They've added a connector onto the back of it so you can plug a cable onto it. There are a lot of packs of screws and assembly things, and what I want to show you about these that I really think is neat is that they actually have written on each one of them what they're for, and as you follow through their instructions, they reference the pack that you're going to need. So for every section, they've got a pack already made with all of the hardware that you need, so that really makes putting this together a lot easier. Now this is an expansion shield that is going to go on top of the Arduino and allows you to connect all these connectors to it. This is the L298N H-bridge motor driver. Now this is a 4-motor car, however they're only using one H-bridge and they're running 2 motors on each side in parallel. So just wanted to let you know there are only one of these in the kit and not 2 of them. They've even included a little bit of electrical tape for tidying up your wiring and that. That's really cute. Now here are the 4 wheels, of course, the car is going to use, and this is pretty typical of these little car kits. And the 4 motors as well. So here they are, and as you can see, the motors have been pre-wired with connectors on them, so that's really nice. And then the base unit itself, and this is quite a heavy-duty acrylic part. There's actually 2 levels to the base on this car. It's a 2-level one, and they've got them nicely labeled off for you, so you can't really go wrong with it. And that's it. That's what's inside the box. So as you can see, there are a lot of quality kits in here. They've thought everything out, including packaging the screws in those individual packages. I really like that. And you get this really neat box as well that you can use for other purposes. So let's take a look at what this car can do right now. And then after that, we'll proceed to go ahead, unpackage these little packages, and build the car. So let's take a look at the Elegoo Smart Robot Car. The Elegoo Smart Robot Car is an Arduino-based robot car kit. There is no soldering, special skills, or special tools required to assemble this car. The kit includes 2 18650 LiPo batteries and a battery charger. It comes complete with all instructions and all the code you'll need to get going. The Smart Robot Car is a 4-wheel design with 2 levels. It has an ultrasonic distance sensor mounted on a servo motor. There are line-following sensors underneath the chassis of the car. There is a Bluetooth remote control module and an infrared remote control module. With the Elegoo Smart Robot Car, you can build a Bluetooth remote control car, an infrared remote control car, a line follower, or an obstacle avoidance car. So let's get working with the Elegoo Smart Robot Car. So here are all the components for the smart car laid out on the workbench so you can get a better look at them. Now first of all, here's the 18650 LiPo batteries. There's 2 of them. And the charger that's also provided, which is obviously going to power the car. Now on this side over here, I have a battery box, and this is actually going to hold the LiPo batteries, and it's got a little switch on it as well too, so this is going to be the on-off for the entire car. Now, as I said, they've taken the hardware and they've put them into individual bags, and they've labeled up the hardware. So for example, these are the motor mounts, These are all the little blocks for the motor. So all of the nuts and bolts and pieces you need for every step of the assembly has been placed into one of these little bags and labeled, and that's really, really handy. Okay, here's a SG90 servo motor. This is what's going to be holding the ultrasonic sensor so it can do the collision avoidance thing. And here's the hardware for the servo. This stuff, which I've kept in the bag so I don't lose track of it, this is the mount for the ultrasonic sensor and also for the servo motor itself, and it allows you to mount the sensor to the servo motor. Now here are some wiring assemblies that are already fabricated for you, so it makes the wiring very easy, and of course the instructions will show you what to connect to what. The 4 tires for the car, they're basically the standard ones that I'm sure you've seen before if you've used any of these little robot car kits. One nice thing about them is they actually use screws, so they've got some mounting screws over here, so and aside from just press fitting onto the motor shaft, they actually get screwed onto it. And here are the motors themselves. There's 4 identical motors. They've already soldered up the cable to it with a connector on it, and they've placed a tie wrap on there as a strain relief. So the people at Elegoo, I'd like to say, have done a very nice bit of soldering there on it. Now here's the components for the base of the car itself. There are 2 pieces. The A label just indicates which end is up. Now this is the piece that's on the top. You can see the cutout on it here for the servo motor. So this will be the top piece. The bottom piece over here, you can see the holes drilled for mounting the motor driver, and also holes for the blocks that mount the motors themselves. And it's very nice acrylic. It's got a little bit of plastic on it that will peel off, but it's a very nice shiny black acrylic, so it's a very good looking little car. Now here's the infrared remote control. Now we've seen these before, we've used them before in one of our videos about IR remotes. I don't know if you can see this on the video because it's transparent, but there's a little tab you pull because there's a battery inside there, and once you pull it the battery makes contact. I'm sure you're familiar with that arrangement. Now once again, the little tools they provided, 2 small Phillips screwdrivers and an Allen key, and I believe the Allen key is to hold the motor mounts down. So you can use these or you can use your own tools. I'll probably elect to use my own, but it's again very nice of the people at Elegoo to supply this with the kit, the roll of electrical tape, and the connection to the Arduino USB connector. And now we get to the meat and potatoes, the actual components that are included in this kit. Now this is the line following sensor. It's got 3 source sensor arrays on it and a sensitivity adjustment. This is an 8CSR04 ultrasonic sensor. We've seen these before. This one has a connector on the back already soldered to it. The L298N motor controller. Again, we've looked at these before. The only difference with this is they've got connectors already placed onto it for the power and for the control signals. And for 2 motors, one on each side, like they've connected the motors in parallel here. And that's perfectly fine as long as you don't exceed the capabilities of the motor controller. And 2 of these motors won't do that. Now this is actually what I told you I thought was really great about Elegoo is their Uno clones and their Mega clones as well too. I use a lot of their Arduino clones, and one little feature about them that's very tiny but I like it a lot is right over here. I hope you can see that. They've put labels down here for all the pinouts right on the connectors as well as on the board, and that is so handy when you're doing prototyping. So although we don't really get to use them in this project, just that little feature is just one indication of the little extra bit of quality they go into with their products. I've always been very impressed by their stuff, and that really impressed me a lot. Doesn't take much to impress me, obviously, but these are very nice little Arduino Uno clones. Now this is the custom shield that's made for the car, and this is really nice. It basically has a place that you plug in all of the different cables. You'll plug the Bluetooth module, which I'll show you in a second, directly into this. This is the infrared sensor for the infrared remote, so I guess the only thing you have to concern yourself is not running any cables in front of that. One thing I like about this is they brought all of the I/O pins on the Arduino, the digital ones and the analog ones, as well as the supply voltages, out the pins here. So even after you build this robot, if you want to start adding extra components to it, extra parts, you can do that. You can get at all the unused pins, and all of the pins actually, right over here. So that's a very nice touch. And finally, this is the Bluetooth module. This is actually equivalent to an 8C05 module. It has a different name, ZS040, but essentially it's a standard Bluetooth module with a connector on it. And as I said, this actually plugs directly into this card over here. And so there you have it, the components for the Elegoo Smart Robot Car Kit. So now the next step would be to start building this device. So let's go ahead and do that. Now, assembling something with as many components as the Elegoo Smart Robot Car may seem a bit daunting to some of you, but don't worry about it. They have provided an excellent instruction manual, and it's available in multiple languages. The manual comes in PDF form as well as Word document form, and it's available on both the CD that's included with the kit and on the download. Let me show you a little bit of the manual. I've got it up here on my computer right now. Look at the diagrams over here. Look at the levels of diagram they have over here. They really go through every step in great detail. And with that kind of detail, I don't anticipate any problem at all assembling the Elegoo Smart Robot Car. So let's go ahead and do that right now. Now, the first step in assembling the Smart Robot Car is to mount the blocks to the motors and then mount the motors to the bottom base. Now, I've already started to do that. I've mounted one of my motors over here to the bottom base so you can see how it mounts. Now, first of all, you need to distinguish your bottom base from your top one, and it's quite easy to do. The top one, which I'll show you over here, has a cutout on it for the servo motor, which the bottom one doesn't have. So both of these were covered in plastic, and as again you notice from the top one there's a letter A on it. There was a letter A on this one as well, and that indicates that this is the side that is facing up. So I've taken the plastic off and I've observed that. Also, you can tell from this bottom one here where these 4 holes are. This is the front of the car. This is where the line following sensor is going to mount. So let me show you how the motors mount. There's a kit of parts inside here that says for motor, and it contains 4 of these blocks, plus 8 of these long screws, 8 of the shorter screws, and 8 of these M3 nuts. And the way that they work is these blocks are used to mount the motors down. So you'll notice there's 2 holes in the motor. Go on the side where the wire comes out, place one of the long screws through the holes, and then put your block on like that, and then grab one of the nuts and then put that on. Okay, just finger tighten that for a moment and put the other screw through. Now, I've brought a few tools out. This is the 2.5 millimeter hex driver that was included with the kit. I've got my own 2.5 millimeter one here as well, and I've also got a pair of pliers just to kind of hold on to the nuts here. So let's just tighten these up a little bit. Should be good for now. Okay, so you have the block mounted to the motor. Now you'll notice on the chassis there are a series of holes that are made specifically for mounting the motor blocks. Now, it doesn't matter which motor that you place in which position. The 4 motors are identical. Just make sure you place it with the wiring on the inside, which you pretty well have to do to mount it correctly. And you're going to take the little screws. They're going to go through the bottom, and they're going to attach into the block. So I'll just get one started by hand over here. Get another one in there. we go. Okay, and then we'll just tighten those screws. Now before you finalize the tightening, you're going to want to sit there and align this thing so that it's nice and flush. And then tighten it really nicely. The blocks, by the way, have threads on both ends, so it doesn't matter which end that you mount them. So that's how you mount a motor. There are 4 of them. I'm going to go ahead and mount the other 2 motors, and then the next step is we're going to put the L298N device onto the motor chassis. So I'll put the other 2 motors on, and then I'll show you how we install the motor driver. So now that I have my motors mounted, the next step is to mount this L298N motor driver onto the bottom chassis. Now in order to do that, there's a package over here that says for Uno L298N. So this is actually used twice during the assembly. Now I've taken out 4 of the long screws, 4 of the nuts, and 4 of the spacers from this package, and that's exactly half the contents of the package. So the rest of these will be used to mount the Arduino Uno onto the top chassis. Now the mounting is fairly simple, although it's a bit tricky in some respects. Pass a screw through here, and you put a spacer on, and then you'll notice that there's 4 holes in the center of the chassis, and that's where the device mounts. Now you want to make sure you mount it so that all of the connectors are facing the front of the robot car. And again, these 4 screw holes here, which I don't know if you can see, indicate the front of the car, because this will be where the line sensor module is going to be mounted. Now the first one you can just basically put in like this. It's getting the other 3 in that are a bit tricky. I'm going to put this in, and I'm just going to put a nut, but I'm not going to fully tighten it. I'm just going to finger tighten this for a moment. And that will hopefully make it easier to get the other nuts and spacers in. It's the spacers that are a little bit of a problem. What you need to do is try to place a spacer somewhere where you can get it right over the hole if possible. Slide that over and slide the screw through like that. Again, I will only finger tighten these until they're actually in their correct space. Okay, they're finger tightened right now. I'm going to use the driver and actually fasten them down a bit more securely. Okay, so now I've got the L298N driver mounted. The next step is to actually plug the motors into it. Now, basically there are 4 connectors over here, and you just want to plug them into the motor that is the closest to the connector. Now the connectors are keyed with a little key on here, so you can't really put them in the wrong way. Alright, and there you have it. The L298N is mounted, and I've got my 4 motors connected to it. Now obviously we'll be making other connections to it later in the assembly process. So the next step that we're going to look at is to mount the line following sensor underneath the chassis over here. Now the next step in assembly is to install the line tracing sensor on the bottom of the chassis. It's going to mount underneath the chassis using these 4 holes over here at the front. Now this is the sensor itself, and this is a kit that says for line tracing, and it's got 4 each of these standoffs, of these screws, and of these M3 nuts. And what you do with these is you actually put the standoffs onto the line tracing and place a nut on there to hold it. There we go. Okay, now I've installed these onto the line tracer module itself. Now I've finger tightened them pretty good, but I haven't permanently tightened them just in case there's some alignment issue. Now, as I said, this is going to go onto the front of the chassis on these 4 screws here, and you want to mount it so that this sensitivity pot is facing forward like this, and the connector is facing backward toward this hole, which is actually where you're going to pass a cable for it. So place a screw through the hole over here and get the first one going. Something like that, and then I can just simply place the other 4 screws in to complete the job. And once you've tightened this down, you can go and tighten these nuts. So here we have the chassis with the 4 motors, the L298N, and the line following sensor underneath it. Now the next step is going to start working on the top chassis and mount the Arduino Uno and its shield on that. So I'm going to do that next. So now I've got the top chassis plate. Again, I've removed the plastic off the top of the acrylic, and I've got it facing with the correct side, the side labeled A, going up. Now, in this case, if you do it the wrong side up, you actually will end up mounting the Arduino Uno in the wrong direction, so you definitely need to pay attention. To tell you the truth, for the bottom plate, you could have flipped it over and it probably would have worked just as well. Now, in this step, we're going to mount the Arduino Uno and the shield that snaps on top of the Uno onto this top chassis. And we're going to go back to this bag that we opened up earlier that says for Uno L298N. And it's got 4 more spacers, nuts, and bolts over here. Now, in truth, we only need 3 of them. Although there are 4 mounting holes on the Arduino, only 3 of them are used, and that's pretty common because, if I may say so, there's one small flaw in the Arduino Uno design, and it's the position of that hole over here. You'll find it's very difficult to mount things there because both the head of a screw and a nut can't really fit beside the connector over here. If you use snap-on connectors at the bottom, you can actually mount with that hole. So you'll find a lot of designs, including this one, don't make use of it. Now, if you look at the bottom chassis, you'll see there are 3 holes over here, and this is where we're going to mount our Uno. So we're going to basically do it the same way that we did with the L298N. We're going to pass a nut through here, sorry, a screw through here, and a spacer. Get the first one in and then just finger tighten it again. Okay, and then we have to sort of do the same thing we did before with the spacers, kind of slide them to the correct spot. Oops. Drop the screw through and put a nut on the other side. And then finally the third one back over here. Okay, once these are in, we can tighten them down. Okay, and our Uno is now mounted on the top chassis. Now, the only other thing to do is to place the shield on it, and of course that's just a standard Arduino shield. So we want to make certain that we line up the holes correctly, of course, all the connectors. And so as you can see, it is lined up, and we just snap that on. And there we go, the Uno and the Uno shield are on here. So the next step is going to be to mount the battery compartment onto this. Now installing the battery holder is quite simple. I've got the battery holder over here with the top off of it. Here are the 2 LiPo batteries that were included with the kit. And I've got this little kit of screws. It says for cell box, and it's got 4 screws and 4 nuts in it. And it's simply a matter of bolting it onto the chassis. Now you'll see on the chassis over here, we've got 4 holes at the back, and this is where the holder bolts. Now, obviously you could put it 2 different ways, but the correct way becomes pretty apparent. When you line it up over here, the holder is exactly centered correctly on the chassis. So I'm going to install this right now. At first glance, you might think these holes are kind of large, but they're actually beveled so the top of the screw head doesn't protrude and push up on the battery. So let's just put the screws in and do that. Alright, let's just tighten those screws up a bit. One thing to note is that these screws are Phillips heads, so they don't use the same driver as the other screws we've used. Okay, there we go. I've got the battery holder in. Now, next step is to place the batteries themselves in. Make sure, of course, that you place them in the correct orientation. And you can then place the top back on the battery holder if you wish. Now the last step here is to connect the output of the battery compartment to the shield on the top over here. Before you do that though, make certain that you have the switch in the off position, because at this point in time we don't really want to send power to the board, although you won't hurt it if you do. It's just not a good idea. So that just plugs in over here, and that's the installation of the battery compartment. So the next thing we're going to install is going to be the servo motor. Now installing the servo motor is going to require a bracket, which you'll find in the same package as the mount for the ultrasonic sensor. You'll also need this screw kit that says for ultrasonic, and from the kit you're going to need the 2 M2 screws and their nuts and the 3 M3 screws. You'll be left with 4 M1.6 screws, and that's for holding the ultrasonic sensor in, which is what we'll do in the next step. Now I've already taken the bracket, I've taken the brown paper off of it, and I've mounted my servo motor onto it. I wanted to show you the orientation of the servo motor. You use the little M2 screws and pass them through the bottom going upward to hold the servo in. You've got the 3 holes over here, and make certain that the servo is oriented so that the shaft is facing this direction. This will be toward the interior of the robot chassis. Once you've done that, you can mount the bracket itself onto the robot chassis, which goes right in the front over here, of course. Pass the cable through. And just place the bracket in there. Line the 3 holes up and use the M3 screws to secure it. Okay, once you've done that, you can secure the screws. And then the final step is to take the cable from the servo, pass it through this hole over here, and hook it up to the connector. Now the connector for the servo is here. You'll notice it's labeled with a ground pin on one side, and ground on this cable is the brown wire. So make certain you orient this correctly. That's very important. And our servo is hooked up. So the next step is going to be to put the ultrasonic sensor onto the top of the servo motor. Now mounting the ultrasonic sensor is going to require a number of parts. First we're going to take the 4 remaining screws and nuts from the 4 ultrasonic bag, and those would be the very tiny M1.6 devices. And we're also going to take an M2 self-tapping screw from the bag of parts that comes with the SD90 servo motor. So take the small self-tapping screw out of there as well. And then you'll need the bracket that holds the servo motor. Now this is actually a pretty simple thing to do, although what's difficult about it is the size of the components we're working with. They're very, very tiny. And what I've found is that the easiest way to do this, if I can use the word easiest, is to take the small screws here, the M1.6s, and start threading them through the holes on the ultrasonic sensor. Something like this. And do that with all 4 of them first, and that way it'll be easier to place it onto the bracket. So then that I've got these screws started, what I'll do is I'll place this over the bracket and get the screws into the holes. Sometimes it's loose enough to push them through, sometimes it isn't. And then start putting these nuts on the back. And once you have them on, you can tighten them. Okay, so now we've got the ultrasonic sensor mounted on its bracket. What you'll do next is you'll place this on to the servo. Now, you're going to want to try to set this so it's facing the front as much as possible, but of course it has to mesh with the servo gears, so it may not be lined exactly 90 degrees. Also keep in mind that later on in the process, you may need to reorient this because it may not actually be centered on the servo. And we'll put the little screw in to secure it. And there you go, our servo is now mounted to the front of the robot chassis. The next step is actually going to be to hook up some of the cables so we can connect all the devices to the shield over here. So now we're ready to just about put everything together. We are going to hook up the cables that are remaining, and we're also going to fasten the top chassis and the bottom chassis together. Now you're going to need these things in the package that says for acrylic base plate, and basically it's got 6 of these large copper spacers and 12 screws to go into them. And you're also going to need the bag of cables, at least the remaining cables that you have. And you should have 2 cables for the L298N, which are these ones over here, a cable for the line following sensor, and a cable for the ultrasonic sensor. So I'm going to put the spacers on the bottom one first. Alright, now that the spacer's on, I can start hooking up some of the cables. So I'm going to do the L298N first. This little cable does the power connection. Now the connectors on the ends of these cables are identical, so it doesn't matter which end you connect to the device and which end goes to the shield. So put the power connector on. And the 6-pin connector over here is the one that actually deals with the data signals going to the L298N. So put that on. Leave that sitting for now. Now the next one we're going to use is this 5-pin cable, and this goes to the line following sensor. So pass the cable through this hole over here, and then connect it to the sensor. Now all of these cables are keyed, so it's impossible to put them in backwards. So now that we have all of these wires over here, let's pass them up through this hole over here on the top chassis. And once we've done that, we can put the top chassis on. Alright, well I'll tighten those screws later. What I want to do is connect these wires to the shield first of all. So we'll start again with the L298N. Connect it to its power connection. And the next connection is its data connection, which is right beside it. And then the connection to the line tracker, which is right at the front over here. Okay, and our final cable goes from the ultrasonic sensor to this connector over here that says for ultrasonic. And we are connected up, except of course I've got to tighten these down. And there we go, our robot car is starting to take shape. In fact, there's only 2 missing items right now, the Bluetooth module and of course the wheels. So we're going to go and do those ones right now. Alright, well I've installed 3 of my tires. I've left one off so I can show you how they're installed. Essentially there is a little kit that says 4 tires. It has 4 of these long self-tapping screws in it. And we have of course the 4 tires themselves. Now you'll notice that the motor shaft is keyed. And so what you do is you get the tire on and press it down onto the shaft and then place the screw in. Now you may sort of have to hunt for the actual screw hole, but once you get it, you just screw it down with a Phillips screwdriver. And we have 4 wheels on our robot car. Now the Bluetooth module is the last component. It's very easy to install. There's simply a socket for it here on the shield, and you place it on. And we have now completed the construction of the Elegoo Smart Robot Car. Now let's go and test this thing out. So now that we have the car assembled, we'd like to give it a quick test to make sure that the assembly is correct and that everything is basically working. Now, as I mentioned at the beginning of this video, this is the first of 3 videos and articles that I'm going to be doing on this Elegoo Smart Robot Car. And in the other 2, I'm going to go more deeply into the code we need to use things like the Bluetooth, the infrared remote, the ultrasonic sensor, and the line following sensor. But today what we're going to do is just make sure that the wiring is okay and that the basic motors are functioning, and Elegoo has provided some code that we can use for that. Now the first test you'll want to do to your car is simply to power it up. And when you power the car on, you should see some lights happening over here. You'll see a light flashing on the Bluetooth module, a green light over here which is actually connected to pin 13, IO13, the same one that there's a light on the Uno board for, a power light. If you take a peek underneath the car, you'll also be able to see some lights on the L298N module. And the fact that you're getting these lights and the fact that they're blinking because the Arduino comes from the factory running the blink program is an indication that you probably have everything wired up correctly. Now, when you are programming this car, there is something I need to let you know. And this is not unique to this car. It's actually something you need to know when you're working with Bluetooth modules in the Arduino Uno. The Bluetooth module uses the serial lines, the data in and the data out, which are the equivalent of pins 0 and 1 on the Arduino Uno. The problem is your USB connector in the Uno also uses those same lines, so you can't have the Bluetooth module in and send code via USB from your computer because it's not going to work. There's going to be a conflict because there's 2 communication devices on the same line. What you need to do is first of all make sure the power is off, and then remove the Bluetooth module. You will need to do this every time you program the car. Just place the module somewhere safe, and then connect your USB cable from your computer up to the Arduino Uno connector, and of course you'll see the lights light up because now it's being powered by the USB connector and not by its internal battery. Leave the battery off, do your programming, and at the end of programming, remove the USB cable, put the Bluetooth module back in, and then turn the power switch on and everything will be fine. But remember, you can't upload data to the car with the Bluetooth module in. So having said that, let's take a look at a very simple sketch they've called. It's just called Auto Go, and all it does is it exercises the 4 motors, actually 2 because there's 2 in parallel on each side, and it just makes the car go backwards and forwards and does a basic test of the car assembly and the L298N. So we're going to take a look at that code right now. So here's the Auto Go sketch as provided by Elegoo. Now it starts off basically defining the operation of the L298N. So it shows you the enable A, enable B line, input 1, input 2, input 3, and input 4. And it basically just in the comment section shows you a little chart that will show you what states you need to set all of these outputs to make the car run forward, backwards, left, or right, or basically just to stop it. Now the next thing we do is we define a few variables that define the I/O pins used to connect to the L298N. So the enable A line is connected to Arduino pin 5, enable B to pin 6, input 1 to 7, input 2 to 8, input 3 to 9, and input 4 to pin 11. Now we define a number of functions. Now these functions are basically all the same. All they do is they set the enable and input lines accordingly in order to move the car in the right direction. So the forward function sets them all up in a specific manner. The back function sets them up in a specific manner. The left and the right function. Again, you can go to the top over here and you can see how those functions correspond to the logic levels you need to send to the L298N. You'll also notice that there's a serial print line over here, so you can use the serial monitor to see which function is currently running. Now remember, if you want to use a serial monitor, first of all you'll need a relatively long USB cable because your car is going to be moving around a bit, and secondly, you will need to run the car without the Bluetooth module because once again the Bluetooth module's presence will prevent the USB port from working in serial mode. Now the serial monitor is optional and I'm not going to use it when I demonstrate my car operation. Now after all the functions we get to the setup. Now some of you may be familiar with the setup being further up in the code, but it really doesn't matter where you put setup, loop, or any of the functions, the code will compile correctly. So in the setup function, we set up the serial monitor at 9600 baud, and then we set all of the pins we just talked about as outputs. And then we go into the loop, and the loop is very simple. We call the forward function, we delay for 1000 milliseconds, which is 1 second. We call the back function, we delay for another second. We call left, delay for a second, and we call right and delay for a second. And then the loop repeats itself over and over again. So the car should move forward for a second, it should move in reverse for a second, left for a second, right for a second, and then just keep going on and doing that. So it's fairly simple code. Let's upload this to our Elegoo robot car and let's see it in action. So I've got the code loaded up to the Elegoo Smart Robot Car, so let's throw the switch on. And it's going through the motions. Looks like it's working. Let's put it down on the floor and watch it go. Seems to be working. Great. Okay. So it looks like our car is working. At least the L298N is capable of driving all 4 motors. And it's a pretty good indication that everything is wired up correctly and ready to go. So this brings us to the conclusion of our first video on the Elegoo Smart Robot Car. Now in the next video we're going to cover both the Bluetooth and the infrared remote, and then we'll finish off with a third video that covers the line following and the collision avoidance capabilities of the car. So there's plenty to look forward to. Now the best way to find out about these videos is to subscribe to the YouTube channel. So if you haven't done that, please click the subscribe button below this video and subscribe to the channel. I would very much appreciate that. Now, as always, you will find an article about the subject we've just covered on the dronebotworkshop.com website, and there'll be a link to the article right below the video. While you're on the website, please consider signing up for my newsletter. Now, this isn't a sales letter or anything. It's just my way of keeping in touch with you to let you know what's going on in the workshop and also to get your opinions on some of the subjects that I'm thinking of covering. And this way, I can make videos and articles that are more relevant to you. So until the next time, please take care of yourself, and I hope to see you again really soon here in the workshop. Goodbye for now.